This is only for civil.
Mechanical, civil, both. Hello dear students, good evening to all of you, welcome to you all. In today's session we are going to discuss about the discrete time Fourier transform, next part. In the last class we have already seen some basic properties of discrete time Fourier transform. I am Ankur Sharma, Associate Director IMS Academy, welcomes you all on this YouTube channel. First of all, you should reply fast guys, am I audible? Audio video is clear to you? Actually every day we are having the session at 6:30 p.m. but because of some technical reason we have just shifted our session from 6:30 p.m. to 5 p.m. today. So maybe students are not aware about it. So let's start the session guys. So student, before going to start the session, I just want to tell you, IMS Academy offers offline courses, hybrid courses as well as live online courses. So if you are from nearby area of Bangalore or Vijayawada, you can join our offline classes in Bangalore and or in Vijayawada. Otherwise, from other city students, you can also attend, you can also enroll in the live online program. Once you will enroll, you will get all the features. You will get 800 plus live lecture access, theory book, exercise book which contain 4000 plus practice question. You will also have 34-year most unique and premium GATE PYQs booklet with QR code video solution. Other features also like alternate solutions, like we can say that key pointers or chapter overviews, 12 personalized one-to-one mentorship session, one-to-one my plan sessions, 130 plus online test with video solutions. Student, if you want to get detailed information, you can also contact on the given number to our student advisory team. Chali, so let's start the next. If I talk about Telegram group, you can Telegram group link is given in description. Once you will join the Telegram group, you will have the access of all these features. So make sure that if you want the PDF of the notes, if you want the update about the PSU job notification, everything you will get here. So student, till the last classes, whatever we have concluded, we have just discussed about the basic signals, discrete time Fourier transform, formula of discrete time Fourier transform. We have seen some examples also, a e ki power minus j omega, a ki power n u of minus n, a ki power mode of n Fourier transform. Everything we have already discussed till the last classes. Even we have started some properties of some properties of the discrete time Fourier transform also. So I think first property we have discussed. I am going to start with the next property. This is the Fourier transform formula only, that we know that it is periodic, that it is, we already know that the discrete time Fourier transform where x of n is a periodic, is a discrete and non-periodic signals. X of n is a what guys? X of n is a discrete plus non-periodic signals. So just wait, let me take the yellow pen here and here white pen. Yes. So guys, here what we have, here we have x of n as a discrete plus non-periodic signal, but it's a DTFT, it's DTFT that we are representing as a x e to the power j omega always will be continuous plus periodic for the period of minus pi to pi. So now student, x of n should be aperiodic and should be absolutely summable. That is why the Fourier transform of a unbounded signal 2 ki power n un, the DTFT is not possible, can't determine. Why can't determine? Because it is not absolutely summable. It is not absolutely summable. It is not stable. चलिए, so del n, of course we know that del n discrete type Fourier transform is 1 only, and a n u n Fourier transform is 1 upon 1 a minus का j omega. Now student, tell me linear property we have already discussed. Now again time reversal property says that if x of n having the Fourier transform x e की power j omega, you can say that dtft discrete time Fourier transform, then x of minus n dtft discrete time Fourier transform will be x of e की power minus का j omega. So this is all about x of n discrete time Fourier transform x of minus n x e की power minus j omega. Now student, simply it means if you will replace n with minus n, if you will replace n with minus n, your omega will be replaced with minus omega. You can also just relate with the formula. When you will write the formula x e की power j omega, you should write the formula like this: minus infinity to infinity x of n dot e की power minus का j omega n. So student, here if you will change the formula from n tends to minus infinity to infinity, here if I will replace x of minus n e की power minus का j omega n. Now what you can do guys, what you can do, you can just replace n with minus n also. So your limit also going to be changed, and e की power omega, in omega value you can make it minus omega. That will only change. Here also I can do like that. I can just replace, if I will replace omega with minus omega, na, then you will get the same. Here x of e की power minus का j omega will be what guys? Sigma of n tends to, n is also changing, so infinity to minus infinity, and here is x of minus n, and here is e की power plus का j omega n. Yes or no? Because minus minus sign has been changed. Yes or no? So if you will replace n with minus omega, if you will replace n with minus n, you have to replace omega with minus omega. So whenever is omega, we can just replace with minus omega. Yes or no guys? Chaliye, similarly if I talk about the next property, that is time shifting property. Time shift property says that if x of n having the discrete time Fourier transform is this, then x of n minus n naught, time shifting always same time guys. Time shifting always have same sign in the frequency domain. So because it minus sign, so it will be e to the power minus का j omega t minus का j omega n naught, माने e की power minus का j omega n naught, और x e की power j omega. Similarly student, if I talk about x of n plus n naught, if we have the positive sign, then what about the dtft guys? The discrete time Fourier transform will be e की power plus का j omega n naught into x of e की power j omega. So this is all about your discrete time Fourier transform. So this is all about your discrete time Fourier transform. I hope you are getting this. I hope you all guys getting the same. We can relate with the properties also by just using the formula. We know that x e की power j omega. This is my dtft formula. So sigma of n tends to minus infinity to infinity x of n dot e की power minus का j omega n. So if I will replace x of n with x of n minus का n naught, sigma of n tends to minus infinity to infinity x of n minus का n naught e की power minus का j omega n. If I want to find out the Fourier of the same, what I am doing here, I am replacing this n minus n naught as a small m. Then what is small n? Small n is nothing but m plus n naught. Just do this guys. So what you will get? You will get sigma of n tends to minus infinity to infinity x of n minus n naught, you will get as a x of m e की power minus का j omega. And what is n? N is nothing but sir m plus n naught. And limit will not change. Why? Because when you will put minus infinity, then m limit is also minus infinity. Because minus infinity minus n naught is nothing but minus infinity. Similarly, plus infinity will also same. So because we have changed the time, so maybe students get not informed about the session. Maybe you can watch in recording guys. So what is the next? The next thing you can say that x of m e की power minus का j omega m dot e की power minus का j omega n naught. So don't you think this circle, this closed curve is nothing but x e की power j omega and multiple with what guys? E की power minus का j omega n naught. It means if xn has a Fourier transform this, then this xn minus ka n naught is having the Fourier transform x e ki power j omega dot e ki power minus j omega n naught. That is why we always say that the time shifting always you have to remember like this, time shift always carry same sign. Time shift always carry same sign. Time shift always carry same sign. Is this clear, beta? So whenever we have the time shift, minus, then plus, yes. So I will take some examples also. Suppose that we have the question x of n as a half ki power n minus 1, u of n minus 1. Can you find out the Fourier transform? Yes, we can start with this. We know that a ki power n un, so half ki power n un, the Fourier transform is nothing but 1 upon 1 minus ka half e ki power minus ka j omega. And if this is true, guys, if I will replace n with n minus 1, I should write half ki power n minus 1 into u of n minus 1, and the Fourier transform is nothing but here 1 upon 1 minus ka half e to the power minus ka j omega, and dot here e ki power minus ka j omega. So this is all a n u n, half ki power n u n, like this. Half ki power n un Fourier transform 1 upon 1 minus ka half e ki power minus j omega. Half ki power n minus 1 u minus 1 Fourier transform 1 upon 1 minus half e ki power minus j omega, same sign. Why same sign? Because minus sign, then minus sign here. If I will write like this ki half ki power n minus 3 u of n minus 3, then it will remain same 1 minus ka half e ki power minus ka j omega, but this time in the exponential we will have e ki power minus ka 3j omega, e ki power minus ka j3 omega or 3j omega, like this. Yeah. So this is all about, guys, time shifting property. This is all about what? Time shifting property. I hope this is clear to you, bachcho. I hope this is clear to you, crystal clear. Chaliye. So let's start the next question, next property, guys. Now sometime may examiner can confuse you. Examiner can ask a question like this, कि sir, find out the Fourier transform of 1 by 4 की power n of u of n plus 3. Yeah. Find out the Fourier transform of this. Examiner can like, and it is a similar type of gate question already asked in the gate. I will show you very soon in today's class only how to solve such type of questions. Okay. So just do it fast, guys. Boli. Shall we go for next or wait? You should try to attempt this question right now. And one more thing, guys, if you have not subscribed our channel yet, you should subscribe our channel so that whenever any new live streaming will be there, you will get updated, you will get the notification. Okay. Chali. So half ki power n u. So how you can start the session? You can start the session by, you can start this question by half ki power n un. What is half ki power n a n un? A n un, discrete time Fourier transform is nothing but 1 upon 1 minus ka 1 by 4 e ki power minus ka j omega. So if I talk about this, ki sir 1 by 4 ki power n plus 3 into u of n plus 3, then what is this DTFT, sir? What is this DTFT, discrete time Fourier transform? Then it will be 1 upon 1 minus ka 1 by 4 e ki power minus ka j omega. 1 upon 1 minus 1 by 4 e ki power minus j omega, and here we have e ki power plus 3j omega. But this is not the actual question. Actual question is 1 by 4 ki power n only. So what should I do? If I will open this 1 by 4 ki power n dot 1 by 4 ki power 3 dot u of n plus 3. Now if you will check the left hand side part, DTFT, in the left hand side part which is not required, half ki power 3 is not required, so can I multiply with 1 by 4 ki power minus 3 both side? 1 by 4 ki power minus 3 both side, yes or no? So ultimately now this part and this part get cancelled and I can achieve my the question expression now 1 by 4 ki power n un plus 3 and it is nothing but 1 upon 1 minus ka 1 by 4 e ki power minus ka j omega dot and here you can write e ki power plus ka 3 j omega. So your final answer will be what guys? Your final answer will be 1 by 4 ki power n u of n plus 3. The discrete time Fourier transform will be discrete time Fourier transform 1 by 4 ki power minus 3. So it will be 4 ki power 3 and e ki power plus ka 3 j omega upon 1 minus ka 1 by 4 e ki power minus j omega. So this is all about our courses. This is all about our this question guys. What is the answer final? 1 by 4 ki power n un plus 3 dtft 4 ki power 3. What is 4 ki power 3 guys? 4, 16, 16 3 ja 16 8 ja sorry yes 1 into sorry 4 into 4 into 4 4 into 4 into 4. So you can say that 64 yes or no. So you can write here 64 also, you can just replace here. Chali. So next property is nothing but guys frequency shifting property. Next property says that frequency shift property. So frequency shifting property says that if x of n is having the discrete time Fourier transform is representing by the x e ki power j omega, then x of n dot e ki power plus j m omega n omega 0 e ki power j omega n e ki power j omega n x of n, then dtft will be what? dtft will be what? dtft will be x of e ki power j omega whatever the sign is there guys e ki power j m omega I should write. Just wait guys, this is x of n. So e ki power plus ka j omega or j m omega. So if plus sign is there then here it should be minus omega minus m like this. And here if I will have the negative sign na e ki power minus ka j m omega into x of n, then its dtft will be what guys? Discrete time Fourier transform will be nothing but x e ki power j. This time minus sign is there, so that is why plus sign is there. So omega plus m. So this is all about the frequency shifting property guys. In the frequency shifting always we have the opposite sign. In the frequency shifting sign always remember we have the opposite sign. Frequency shifting always we have what? Opposite sign. Is this clear to you? Is this clear to you beta? So you can relate with the properties also with just like this formula. What is x e ki power j omega formula guys? The formula is nothing but sigma of n tends to minus infinity to infinity x of n dot e ki power minus ka j omega n. But in place of x of n, if I will replace this entire value, then what I will get? I will get from here sigma of n tends to minus infinity to infinity. Here I will write x of n dot e ki power minus ka j omega, and this n e ki power, this x of n I am writing with white xn e ki power plus ka j m omega, and dot I am also writing here e ki power minus ka j n omega or j omega n. So don't you think ultimately we can write like this sigma of n tends to minus infinity to infinity x of n dot e ki power minus ka j omega. Minus already taken outside guys. If minus already taken outside, then what is left inside? Inside the bracket you will get n minus ka m. So don't you think that now because it is x e ki power j omega, now here the factor j omega because n is multiple, but here n will be n minus m, or you can say that e ki power j e ki power j omega minus m. Omega we have taken common guys, yes or no? Just wait. Actually it is omega 0 guys. Shubhanshu Shubman Kumar Singh. Yes beta, yes beta. Good evening beta, good evening. Actually here m value, yes, m value is there. So e ki power in terms of what we can say that e ki power, let me just change guys the value. This e ki power j omega 0 n, not m omega. Let me change the property, frequency minus frequency only. So I am writing here e ki power plus j omega 0 n x of n और e की पावर माइनस का j ओमेगा 0 n x of n, ये that I am writing e की पावर j omega 0 n e की पावर minus, so it will be omega minus omega 0, it will be omega plus omega 0. Now it will be what guys, it will be opposite sign, so it will be omega minus omega 0, it will be omega minus omega 0 and it will be omega plus omega 0 actually. So here also the same, I am doing just same opposite sign. So here is n should be there, but omega 0 will be shift. Plus sign means minus, opposite sign, opposite sign. So here x of n will, if replaced with e ki power plus ka j omega 0 n, the remaining formula will remain same, e ki power minus ka j omega n. Then in the next equation what you can do, you can take common e ki power what guys, minus ka j omega. Now what is left inside the bracket? What is left? E ki power minus ka j n common, e ki power minus ka j n common. Then what is left inside the bracket? Left inside omega minus omega naught. Yes or no beta? So that is why e ki power minus j omega minus omega naught here. Because of this, this complete will be represented as x into e ki power j omega minus omega naught. So what is the learning? If x of n having the DTFT this, then complete x of n e ki power j omega 0 n having the DTFT Fourier transform e ki power j omega minus omega naught. Similarly, if I have the minus sign, then it will be plus. I hope this is clear to you beta. I hope this is clear to you beta, yes or no? चलिए शुभांकर शुभम कुमार सिंह beta, is it your first class or you are attending the last classes also? Now suppose that student, I am taking one more example here. Suppose that the question is find out the Fourier transform of e ki power j 4n or 1 by 2 ki power n un. Find out the Fourier transform of this. So here you can identify e ki power j omega 0 n, so omega 0 value is 4. So you can apply the property, like half ki power. First of all you should know a and un Fourier transform can only possible if a value is less than 1 and half value is of course less than 1. So you can write here 1 upon 1 minus ka half e ki power minus ka j omega. And because we have here e ki power j 4n and 1 by 2 ki power n u of n, then what is the Fourier transform guys? The Fourier transform is nothing but 1 upon 1 minus ka half e ki power minus ka j omega. E ki power plus j 4n, opposite sign will be there. As I told you, property says that whatever it is, omega will replace as omega minus 4. So wherever is omega, omega minus 4. This is the only answer guys. This is the only answer. Yeah. Just apply the frequency shifting property. We know that x of n is having the Fourier transform x e ki power j omega, then e ki power plus ka j 4n x of n having the Fourier transform of x e ki power j omega minus 4, e ki power j omega minus 4, e ki power j omega minus ka 4. Yeah. Is this clear to you? Just do reply fast. I hope it is clear to you guys. I hope it is clear to you. It must clear to you. Yes or no guys? Chaliye, so one more property we have guys, one more property we'll discuss about. Before that, this question is very easy, already solved this. So let me take 1 upon 1 minus ka half e ki power minus ka j omega, and here is minus 1 means e ki power minus ka j omega. This is the only answer for this question. Yes. So now next question what guys? What is the next question now? Next question we have scaling property guys, scaling property. So what scaling property says that, guys, if x of n is having the discrete time Fourier transform x e ki power j omega, then x of n by k is having the DTFT of discrete time Fourier transform of x e ki power j omega k. This is the scaling property. This is the scaling property, yes. Just do it fast. So student, we can relate with this with the formula x e ki power j omega. Formula is what? Summation of sigma of n tends to minus infinity to infinity x of n dot e ki power minus ka j omega n. Then sigma of n tends to minus infinity to infinity. If I replace x n by k here, then what will happen? X of n by k e ki power minus ka j omega n. So what I am doing, I am putting n by k as a m. Then what is n, guys? So you can say that n is nothing but mk. Yes or no? So we can do these changes. So if I will do these changes, then what I will get? I will get the limit in terms of m. So m tends to minus infinity to infinity. Now x of m, I need to make space some here. Yes. So it will be e ki power minus ka j omega. And here n will replace as a mk. So what I can write, I can rewrite as a m tends to minus infinity to infinity x of m e ki power minus ka j omega m ki power k. And that is why the k power is multiplied here, e ki power j omega k. It is also multiple, it can be power also. So this is how we can relate with the property. We can just relate with this property. Yes or no, bachcho? Chali. So one more important property we have, differentiation property. Differentiation property. So guys, the next is, this property already we have seen. Now differentiation property. Differentiation property. What is the differentiation property says that, guys? If x of n is having the Fourier transform of x e ki power j omega, then nxn Fourier transform will be j dx e ki power j omega upon d omega. So this is all about differentiation property. Again, very important property. Gate question has been asked. We can also simply relate the property with the simple write the formula of x e ki DTFT formula by putting sigma of n tends to minus infinity to infinity x of n dot e ki power minus ka j omega n. Dot x of n e ki power minus ka j omega n. Yes or no? Now student, when you will differentiate both sides, so you will get dx e ki power j omega upon d omega is equal to sigma of n tends to minus infinity to infinity. When you will differentiate this with respect to omega, so what you will get, guys, here xn as it is now, and here also you will get in the bracket minus ka jn in the bracket, and here it will be e ki power minus ka j omega n. If I will multiply both sides with j, because I want to design this j dx e ki power j omega. So my left hand side will be j into dx e की power j omega upon d omega is equal to this j and this j become j square, and j square means minus 1 minus minus plus. So it will be what, guys? It will be n tends to minus infinity to infinity x of n, and even here what, guys? Shall I write here n? Yes, n. So n x of n and e की power minus का j omega n. So this is all about the property. It means if x of n is having the Fourier transform x e की power j omega, then n x of n is having the Fourier transform of j dx e की power j omega upon d omega. Very, very important. Very, very important property, beta. Shubham. Chali. So student, if I am asking this question to you, find DTFT of, find discrete time Fourier transform of x of n, and where x of n is n a की power n u of n. ये x of n is n a की power n u of n, n a की power n u of n. This. How to solve, guys? We know this property simply a n u n. A n u n Fourier transform is what, guys? A n u n Fourier transform is nothing but 1 upon 1 minus का a e की power minus का j omega. 1 upon 1 minus a e की power minus का j omega. This is our Fourier transform. This is our Fourier transform. This is our Fourier transform. Is it clear? Now, student, if you apply this property, if this is x of n, then this is x e की power j omega. If I will multiply with n, so n into a की power n u n, what is the Fourier transform? The Fourier transform is nothing but 1 upon, even property says that n x of n is nothing but j d by d omega with respect to what, guys? Here 1 upon 1 minus का a e की power minus का j omega, bracket close. So here you will get n a की power n u n. The Fourier transform will be what, guys? J, and here you can make the square 1 minus का a e की power minus का j omega का whole square. Similarly, student, 1 minus a e की power minus j omega as it is, or differentiation of 1 is 0, minus 1 you should write. Differentiation of 1 with respect to omega 0, and here minus का a as it is, and e की power minus j omega, differentiation with respect to omega, you will again get minus का j and e की power minus का j omega. So what is the ultimate answer you will have, guys? Tell me. J and j, again j square. Tell me what final. Is it minus plus and again j square? This is also minus, na? So ultimately you have plus sign actually. This minus minus plus and j square again plus. So ultimately you will have a into e की power minus का j omega upon 1 minus a e की power minus j omega का whole square. Just note down this important result. A e की power minus j omega, a e की power minus j omega upon 1 minus a e की power minus j omega whole square. Abhishek writing that. Sir, you will be also teaching some root locus and Nyquist float in control system, please. Abhishek, I want to teach, but I am very much disappointing whenever I am starting the classes now. Students are not attending in the live manner. So that is why we don't have such motivation to teach on YouTube in a live manner. Maybe I will plan some recorded sessions for you, okay? If you want the recorded sessions of root locus, we'll plan that. Okay, beta? Yes, chali. So here, student, what is the important note? What is the important note? Acha, have you completed signals and system playlist, beta? Abhishek, have you completed signals and system playlist? I hope you completed. So Abhishek, are you IMS students? One IMS, one like that, your number is there. So if this is x of n, guys, x of n is having the Fourier transform x e की power j omega, then the result is not even, I can make this result as a box. If a की power n un is having the Fourier transform 1 upon 1 minus ka a e की power minus ka j omega, then the answer will be what, guys? Answer will be n into a की power n un, and the Fourier transform is nothing but a dot e की power minus का j omega upon 1 minus a e की power minus j omega का whole square. So important note, guys, this is the important note down fast. So I think because this class is scheduled at 6:30 and we have preponed the class, so that is why maybe some students are not attended. So if you are IMS student, then definitely we are having the controls NIQ's plot in the live online batches. Now I have watched sir jet transfer signal foundation lecture. Very good, beta Abhishek, very good. Even if you are the offline students or online students, you have opportunity to complete the subject in detail in our paid courses, in our live online app. Okay, beta, n half की power un. So what is the a value here? A value is half. So you should write a value half e की power minus का j omega upon 1 minus a value is half e की power minus का j omega whole square. So this is all about your, this is how you can use this, this is how you guys can use this property. Yes or no? Chaliye guys. So next, let's go for next. This is already discussed, we discussed. Property already we discussed, guys. If n minus 1 ka whole square xn, then how can we write the Fourier transform in form of? So just open this, so a minus b ka whole square, so n square minus ka 2n plus 1, and here x of n. So what it will be, just open the bracket, so yn will be, actually it will be n square into x of n, minus ka twice n into x of n, and plus ka x of n. And if I will take the Fourier transform both side, if I will take the Fourier transform both side, then I will get for sure y e की power j omega is equal to, do you know xn Fourier transform is x e की power j omega. So n square, it means j square d2 upon d omega square, and here we should write x e की power j omega. Yes or no, guys? Remove this bracket, so d omega square, and here we should write x e की power j omega. And minus का twice, here is j dx e की power j omega upon d omega, because nxn, and plus here x e की power j omega. So this is y e की power j omega in terms of x e की power j omega. Simple question, very easy. Just apply the property, you will get the answer, beta. Yes or no? So Abhishek, I hope it is completed, beta. Shall we go for next? And next property is again very easy. Convolution in time is nothing but multiplication in frequency, just like CTFT, we know that. If x of n having the Fourier transform x e की power j omega, so convolution in time is always will be the product in the frequency domain. So this is nothing but the discrete time Fourier transform. This is nothing but what? Discrete time Fourier transform. Chali. So next, guys, if I want to find the convol of x1 and x2n, so we know that sir x1n, by using the property x1n convolution with x2n, convolution in time is nothing but Fourier transform in frequency. So x1 e की power j omega dot x2 e की power j omega. ये x1 e की power j omega dot x2 e की power j omega. And we know that x of n is nothing but half की power n un convolution of 1 by 3 की power n un. So what is the Fourier transform, guys? Its Fourier transform will be what? 1 upon. Its Fourier transform will be 1 upon 1 minus का half e की power minus का j omega, and dot 1 upon 1 minus का 1 by 3 e की power minus का j omega. I hope this is clear to you guys. Just make it fast. Just do it fast. I'm just waiting for you. Chali. Abhishek, is this completed, beta Abhishek? I am expecting this gate question from you, beta Abhishek. If you understood the last 15 to 20-minute class now, then you are eligible to solve this question. I am expecting correct answer from you all. Abhishek and one more student, Shubham. So 1 minute time I am giving to you. Chali. Try to solve this and tell me the answer. Try to solve this and tell me the answer, guys. Chali guys. So I think correct answer is what, guys? You should write here like this. So 2 by 3 ki power n un. The Fourier transform is nothing but 1 upon 1 minus ka 2 by 3 e to the power minus j omega. And if I will write like this, ki sir, nahi 2 by 3 ki power n plus 3 into u of n plus 3, then its Fourier transform will be what, guys? Its Fourier transform will be 1 upon 1 minus ka 2 by 3 e to the power minus ka j omega. And here also we should write e ki power plus ka 3 j omega. But what you don't want, sir, if you will open this, then you will get 2 by 3 ki power n dot 2 by 3 ki power 3 and dot u of n plus 3. So its Fourier transform will be actually e ki power plus 3 j omega upon 1 minus ka 2 by 3 e ki power minus ka j omega. And here what we don't want 2 by 3 ki power 3. So can I multiply with 2 by 3 ki power minus 3 both side? So 2 by 3 ki power minus 3 both side. So if I will do this, this is get cancel out and this is eventually become my question only. And whatever is here, we know that omega equal to 2 pi f. We know that omega equal to 2 pi f. So when you will replace in terms of omega as a 2 pi f here and here, you will exactly get the same expression. So now you can only compare the coefficient a, and the a value comparison, after comparing the a value is nothing but actually 2 by 3 ki power minus 3, which is eventually equal to 3 by 2 ki power 3. And 3 by 2 ki power 3, it means what, guys? 1.5 ki power 3. So the final answer is nothing but what? Bolo. Final answer is nothing but what? You can just calculate 3.375. Beta Abhishek, no, a is not 1, beta. Abhishek, a is not 1, 1.5 ka whole cube actually. So 3.375. Abhishek, beta, 3.375. If you know the 15 cube, then also you can solve. If you know the 15 cube, then also you can solve, guys. If you know the 15 cube, then also you can solve, yes. Chani. So one more good question we have solved. Shall we go for next now? Chali guys. We will discuss the Parseval theorem in next class. Before that, we will discuss this gate question. चलिए. This time I am expecting this question. Abhishek, at least last question you are not able to attend, beta. This question at least you should try. I am giving you this time 2 minute time. I am giving you this time 2 minute time to you. Just try to attempt this. चलिए guys. So student, x of n is given to you half की power n un, but yn is given x square n. So first of all you have to design yn, which is x square n. So when you will make it square this, you will get 1 by 2 की square is nothing but 1 by 4. So 1 by 4 की power n into u of n. 1 by 4 की power n into u of n. Now student, examiner asking y e की power j omega, but omega equal to 0. So can we take the Fourier transform first of all? So Fourier transform is nothing but 1 upon 1 minus 1 by 4 e की power minus का j omega n. E की power minus j omega only. E की power minus का j omega only. Yes or no? 1 upon 1 minus a e की power minus j omega. 1 upon 1 minus a e की power minus j omega. And we know that कि sir if this is my y of n na, then actually it is working as a y e की power j omega, sir. And if I will put omega equal to 0 in this, then eventually what I will get? I will get 1 upon 1 minus का 1 by 4. E की power 0 तो 1 ही है. Then 4 minus 1 is 3, so ultimately you will get 4 upon 4 minus 1, so you will get 4 upon 3. 4 upon 3 you will get, guys. You will get 4 by 3, guys. Yes, 4 by 3 is the final answer. Abhishek, you will get the answer 4 by 3. Yes or no? चलिए. So one more easy question. Same question we have solved already. Yes. So this is the last question of today's class, guys. Just try to attempt this. Abhishek, if you are here, just have a try for this question, beta. Chaliye. So I am solving this question here, guys. I hope you know the standard forms. If you know the standard forms, you will easily solve this question. AN Fourier transform, Fourier transform is nothing but 1 upon 1 minus ka a e की power minus j omega, and where the condition is mod of a should be less than 1. Similarly, one more standard form we have, a की power n u of minus n, and the Fourier transform is nothing but 1 upon 1 minus ka a inverse e की power plus j omega. In this case, mode of value is greater than 1. And of course, the constant part we can definitely multiply both sides. So this is the box. If you know, remember this box somehow till the date of GATE exam, then you can solve such type question easily. So now you can just map with, this is representing the second form, k value is 2. So 2 into 3 ki power n, u of minus n, the Fourier transform is nothing but 2 as it is, and 1 upon 1 minus 3 inverse and e ki power plus ka j omega. And do you know 3 inverse is nothing but 1 by 3. So answer will be 2 upon 1 minus ka 1 by 3 e ki power plus ka j omega. So this is your final answer, guys. 2 upon 1 minus 1 by 3 e ki power j omega. E ki power j omega. I hope this is crystal clear to you. I hope this is crystal clear to you. बोलिएगा. Shall we go for next or wait, guys? Abhishek, shall we go for next now? Chale guys. So that's all from today's class, bachcho. We'll meet in the next upcoming classes as well. Okay. But maybe guys, maybe the upcoming classes will be in the recording form or short form, because in the live classes I am seeing that students are somewhere busy, so no problem. Chale bachcho, I think today reason is different actually. Today we have pre-planned the class 6:30 to 5. So maybe some students not informed for the same. So guys, if you will enroll in the live online batches now, then you will get all these benefits. You can see the benefit, and if you have not subscribed our channel yet, just subscribe it to YouTube channel, so that whenever any short videos, whenever any informative video, job notification, live lecture come, then you will get informed. 800 plus live lecture access you will get, guys. You will get theory book, exercise book, 4000 plus questions. You will get 34 years GATE question booklet, which having some unique features, that is chapter overview. We can say that the key pointers, alternate solutions, 12 one-to-one mentorship session also you will get. You will get 130 test series. That is we are the only institute who provide such type of GQB booklet, where you will get 2 booklet. So I thought class is, yeah, Hemant, sorry beta, sorry. Hemant, actually the class supposed to at 6:30 beta, but actually because of the studio's issue, so that is why we have pre-planned the class today. So no problem, it is not your mistake beta, but sorry for pre-planned we have class. Okay, so recording is available. You can just have a recorded videos. Okay, you can just watch the recorded videos. Okay, bachcho, chali. So bye bye, take care. That's all from today's class. We are the only institute in India who provide 130 plus online test series, which include subject test, multiple subject test, mock test, and all. If you have not joined yet Telegram group, guys, just join the Telegram group, so that you will get the instant notification about the lecture PDF, important updates, seminar, webinar, PSU notification, expert session, daily quizzes, and many more. Okay, sir, no problem. Beta Hemant, bye bye. Take care. Okay, guys, so that's all from today's class. We'll meet in the upcoming classes. Okay.